NASA's Explorer-1, a conspicuous space test, has given an interesting window into space for Earth. Explorer-1, celebrated overall for its wonderful excursion. Through the scope of room, it was initially made arrangements for a 5-year mission. Surprisingly, this persevering rocket has overcome all presumption, outperforming almost 50 years in activity. In a critical improvement, Explorer-1 has, as of late, identified a huge number of unidentified articles crossing space. The inquiry emerges: what are these unidentified flying articles? Go along with us as we dig into the revelation of how Explorer-1 recognized 300-odd articles in its way through space, while we value Earth's shocking normal wonders like streaming wellsprings, transcending mountains, and dynamic biological systems. Getting a handle on that is fundamental. Our planet offers just a concise impression of the superbness. Looking for us in the universe for a really long time, researchers have considered the privileged insights past our sun-oriented framework, and the cautious look of the Sun Explorer-1 arose as mankind's aggressive mission to look for replies to these immortal inquiries, wandering past the cutoff points of our most impressive telescopes. This space device has accumulated first-hand information about the huge interstellar space, sending it back to Earth following quite a while of startlingly effective excursion. Explorer-1 sent a stunning message that left researchers astounded. NASA's generally trusted interstellar space test announced the area of 300 unidentified items in space, prior to uncovering the secret behind these unidentified items. Let us investigate one of the most fascinating accounts of human space investigation. In August 2012, Explorer-1 accomplished a surprising achievement by authoritatively arriving at the limit of our sun-based framework, known as the heliopause. However, this accomplishment was a long way from direct. As Explorer-1 voyaged farther from the Sun, its power source, 3 radioisotope thermoelectric generators, faced challenges because of lessening sunlight. These clever gadgets convert plutonium-238 rot heat into power. The declining heat yield has prompted decreased power, affecting different locally available frameworks. To save energy, unnecessary frameworks and instruments have been deactivated or put in lethargic states. All things considered, further improvement or closure of critical frameworks might be necessary to drag out Explorer-1's functional life. The huge distance between Explorer-1 and Earth presents extra difficulties. Signals require over 21 hours to go, with powerless signals joined with obstruction and temperature limits presenting obstacles to powerful information transmission. Progressing from the heliosphere to interstellar space presented Explorer-1 to different temperature conditions. Outrageous cold could influence materials, electronic parts, and frameworks, influencing AC in primary respectability. The scanty conveyance of residue particles in interstellar space further poses gambles, potentially causing mileage on the rocket. Other than NASA's profound space network faces difficulties in making do, with restricted assets for Explorer-1 correspondence. This shortage hampers information recuperation and the transmission of solid orders, as sign strength consistently diminishes. Now, let us stop and dive into the uncommon accomplishments of the Explorer tests, culminating the unmatched achievements preceding the new revelation of 300 unidentified items. The victories of the Explorer twin tests act as confirmation of human resourcefulness and the unyielding soul of investigation. A while back, these uncommon space contraptions left on a notable excursion that eternity changed our comprehension of the far-off universes inside our planetary framework. Their initial perceptions of Jupiter and Saturn's moon broke assumptions, revealing geologically active moons that stuck out distinctly from the at first observed infertile surfaces like our moon. Among the Explorer tests, Explorer-2 stands apart for its exceptional accomplishments. In 1986, it cut its name in history by turning into the first rocket to move toward Uranus closely, offering humankind its debut up-close experience with this mysterious planet and its moons. 3 years after, Explorer-2 achieved another significant achievement with a flyby of Neptune, unraveling the secrets of this cold giant. To this day, Explorer-2 remains the only test to venture into the domains of Uranus and Neptune, a testament to its pioneering spirit. As the Explorer rocket continued their incredible odyssey, NASA carried out measures over the past few years to extend their operational life expectancy, deactivating unnecessary parts and heaters to preserve energy, ensuring these courageous travelers can continue their mission well into the next decade. With an anticipated mission end date set for 2025, this is a testament to the strength and toughness of the Explorer tests. For the dedicated researchers and engineers involved in this exceptional endeavor, the climax of the Explorer missions is both a moment of pride and a tinge of sadness. Their persistent dedication and unwavering efforts have surpassed initial assumptions, providing significant insights, exciting scientific discoveries, and captivating the imagination of scientists and space fans worldwide. The Explorer tests stand out for their meticulous design as solid platforms featuring a rotation rate north of 10,000 times slower than the hour hand of a clock. This engineering minimized visual blurring while capturing images and data during their fast journey through space. Their outstanding imaging capabilities dumbfound scientists and the public alike. Even prior to reaching the outer planets, the Explorer shuttle amazed with their imaging ability. Months before coming to Jupiter, they sent interesting photographs of the gas giant, demonstrating swirling clouds and the iconic Great Red Spot. However, the discovery of active volcanoes on Jupiter's moon Io got everyone's attention. The rocket's instruments identified specific signs, confirmed by striking pictures, revealing towering volcanic plumes and a surface scarred by volcanic eruptions. While the cameras of the Explorer space apparatus were ultimately shut down before their interstellar endeavor, they didn't capture images of Mercury and Mars due to various factors. In addition to the Explorer 1 and Explorer 2 interstellar tests, NASA worked other eminent space apparatus like Trailblazer 10, Trailblazer 11, and New Horizons. Explorer 1 marked a prominent moment on February 17, 1998, passing by Trailblazer 10, making it the farthest shuttle at the time. Explorer 1 continued its single process for 14 more years before entering interstellar space on August 25, 2012, a significant achievement publicly announced by NASA in 2013. Adding to the interest surrounding the Explorer missions, one approach that shone was the gravity assist moves. These moves played a pivotal role in pushing Explorer 1 and Explorer 2 on their trying mission to explore the outer reaches of our solar system. To reach distant destinations and gather valuable data, the rockets participated in a heavenly hit the dance floor with heavyweight planets, using their massive gravitational draw to slingshot themselves forward on their grand tour of the planetary system. By taking part in the heavenly hit the dance floor with heavyweight planets, the Explorer tests not only saved significant fuel but also gained the necessary speed to embark on a brilliant tour through the local planet group, leaving behind a lasting legacy of exploration and discovery. Now, as Explorer 1 eagerly gathers and sends significant data back to Earth, scientists face the task of analyzing this information to unravel the mysteries of the universe. Amidst the complexities of space, the persistence of the Explorer missions embodies humanity's enduring quest for knowledge and exploration of the universe. As we ponder the achievements of Explorer 1 and Explorer 2, we are reminded of their significant impact on our understanding of the local planet group and beyond. These missions have not only expanded our scientific knowledge, but have also inspired generations to keep exploring the vast universe, fostering a sense of wonder and curiosity in what lies beyond our planet. Continuing to stretch the boundaries of space exploration. Looking forward, the legacy of the Explorer mission serves as a testament to the creativity and determination of the scientists, engineers, and astronauts who made these incredible journeys possible. Their discoveries continue to shape our understanding of the universe and pave the way for future missions to unravel the secrets of space. In conclusion, the Explorer missions stand as achievements in human exploration, demonstrating the power of curiosity and persistence in unlocking the mysteries of the universe. As we celebrate their achievements, we anticipate the next chapter of space exploration and the discoveries that await us beyond the stars. In a consistent stream of data, another discovery has interested specialists worldwide. A signal that baffled and captivated. Explorer 1 recognized the presence of 300 dim objects crossing interstellar space. These unidentified objects, arising out of the depths of the universe, challenge our ongoing understanding of the universe. However, the fascinating point is that when Explorer 1 communicated the data, it seemed mixed and incongruous. This exceptional event raised numerous questions. However, answers remained subtle. Despite the difficult nature of the communicated data, Explorer 1 itself remained in salvageable shape, continuing to work in amazing condition. Its communication link with Earth remained steady, and the signal held its strength, allowing critical data to be sent to NASA without significant issues. Notably, none of the shuttle's fault protection systems were set off, indicating it had not entered a protective safe mode, as would happen despite risks. It became clear that Explorer 1 was not experiencing an attack, leaving scientists to ponder the cause of the mixed or erroneous telemetry data. Might it someday be interference from external cosmic forces like radiation or high-energy particles? Or might it be attributed to an entirely unknown peculiarity lurking in the depths of interstellar space? To reveal the truth, a thorough examination of various potential factors became necessary. NASA's assessment team embarked on a comprehensive evaluation of Explorer 1's system, considering the impact of cosmic radiation on electronic components and exploring the possibility of temperature changes affecting the reliability of its delicate instruments. While it was speculated that something unusual could have happened just before Explorer 1 reached the heliopause, further investigation showed that the challenges during that transition would not have caused the data scrambling. The team explored the complexities of Explorer 1's communication systems, examining possible signal distortions caused by cosmic interference, or subtle changes in its trajectory. This journey for answers required a careful examination of every potential factor. Spanning weeks, the assessment process included high-level data processing techniques, innovative algorithm development, and simulation of various scenarios to isolate the root cause of the extraordinary telemetry anomalies. After weeks of receiving mixed data, scientists and engineers successfully restored the clarity and integrity of the data from the farthest reaches of interstellar space. The source of the problem was traced back to Explorer 1's attitude determination and control system, specifically to an unexpected source, a dormant onboard computer. Incredibly, this non-functional computer had somehow started working, leading to the corruption of telemetry data. However, the rest of the rocket system remained functional, and data collection activities continued unhindered. With the problem identified, the team immediately devised a solution, sending a command to Explorer 1 to activate the backup system to switch to the correct computer for sending telemetry data. Although this fix involved somewhat of a risk, it required immense patience due to the significant time delay caused by the vast distance between Earth and Explorer 1, with radio signals requiring almost 22 hours to travel. Another challenge presented itself. Explorer 1 was built many years ago, requiring the team to consult several manuals from the 1970s. With careful evaluation, they considered a clear and effective solution: resetting the system responsible for data transmission. By implementing this plan, they resolved the issue without compromising other portions of the shuttle. The result in restoring Explorer 1's communication stream was a testament to the expertise and dedication of the experts involved. Their efforts highlighted the importance of utilizing past data and combining it with current technology to overcome challenges in space exploration. Engineers suspect that Explorer 1's deviation into using the non-functional computer was triggered by a faulty command received from another onboard system, suggesting an underlying issue within the shuttle's complex computer network. Despite this concern, mission leaders remain optimistic yet cautious, emphasizing that the event does not pose a significant risk to Explorer 1's long-term viability. The adaptable probe quickly recovered from the error and continued its mission following the correct computers, marking another win in its exploration process. With this successful reprogramming, Explorer 1 achieved a significant milestone by reaching the heliopause, the boundary signifying its entry into interstellar space. The heliopause, located around 123 astronomical units from the Sun, is a critical boundary where the solar wind from the Sun encounters the interstellar medium. This boundary defines the outer edges of our local planet group and represents the edge of the heliosphere, the region influenced by the Sun's magnetic field and energetic particles. The heliopause's fluctuating shape is influenced by the interstellar gas wind caused by the Sun's movement through space, contributing to its unpredictable evolution and direction. When Explorer 1 and subsequent probes crossed the heliopause, several astonishing peculiarities unfolded. Early, there was a striking reduction in the temperature of the solar wind's charged particles as the test ventured beyond the direct influence of the Sun's emissions. Not enduring this boundary's environment, Explorer 1 continued its mission unfazed. Additionally, the direction of the magnetic field experienced a change, reflecting the altered influence of interstellar magnetic forces. Furthermore, there was a significant increase in the detection of cosmic rays, high-energy particles originating from distant cosmic sources, becoming more pronounced beyond the heliopause. While these peculiarities provide valuable insights into the transition from the Sun's region to the infinity of deep space, there is no evidence to suggest extraterrestrial involvement in Explorer 1's recent detection of 300 unidentified objects in interstellar space. The emphasis remains on scientific exploration and unraveling the mysteries of the universe through careful examination of the data sent by the space probe. In November 2018, Explorer 2, continuing in the steps of its predecessor Explorer 1, crossed the heliopause and entered interstellar space. This achievement marked a significant milestone in our understanding of the boundary between the planetary system and the interstellar medium. Explorer 2's experience at the heliopause provided a unique opportunity for scientists to compare observations made by both space probes, enhancing our understanding of this divine boundary.